Let f is defined from -2 to 10 to q be a continuous function such that f of -1 is equal to 1 and g of x is equal to greatest integer of f of 2 into log x into signum of fractional part of x minus f of 3 upon f of 4 plus f of 5, where x lies between f of 6 to f of 7 plus f of 8 plus f of 9. We have to find the number of discontinuous points. This symbol represents the fractional part function, and this f of 2 ln x is inside the greatest integer function. Here this -2 to 10 represents the domain of the function, and this q represents the codomain of the function. Also, f of -1 is equal to 1, and it is given that this function is a continuous function. Now this set here represents the codomain, and we know that range is always a subset of this codomain. Here this q represents the set of rational numbers. So if I say, let's take an example, the range of the function is kind of this. Now let's assume that at -2 the output of the function is half, and at 10 the output of the function is 5, and f of -1 will give us 1. It is given here. So clearly I can say range belongs to 1/2 to 5. But if we pay attention on this interval, we can clearly see that this interval consists of rational and irrational numbers. Between half to 5 there are numbers which are rational, and there are irrational numbers also, like under root 2, under root 3, under root 5, etc. But codomain here is rational number. Range is a subset of rational number. We cannot have a range from where we can have rational and irrational number. So clearly this graph is not adjusting with the facts and the given information. So from here we can conclude that this function is a constant function with the value which gives always 1 as output. At x equal to -1 it will give you 1, and for every input it will give you 1 as output. So clearly I can, now we know that f of x is equal to 1. So from here I can clearly see that f of 2, f of 3, f of 4, f of 5 are always equal to 1, because it's a constant function for every value of x. So this gx becomes 1 into log x signum of fractional part of x minus 1 upon 1 plus 1, which on simplifying becomes gx is equal to greatest integer of log x signum of fractional part of x minus 1/2. Now let's check the suspicious points for greatest integer function and fractional part function. First of all, since we know that both greatest integer and fractional part function breaks whenever the input is integer. So for greatest integer of log x, at x equal to 1 it becomes log 1, and log 1 is equal to 0, and greatest integer of 0 is also 0. And at x equal to e it becomes log e, and greatest integer of log e is equal to 1. So these 2 points are suspicious for log x, for greatest integer of log x. It is given in the question that x lies between f of 6 and f of 7 plus f of 8 plus f of 9. We know f of x equal to 1. From here x becomes f of 6 is equal to 1 and f of 7 is 1, f of 8 is also 1, f of 9 is also 1. So from here x lies between 1 to 3. So that clearly means that fractional part of x at x equal to 1, 2 and 3 becomes 0. The fractional part becomes 0 at integer always. Since we know that signum of x is equal to 1 whenever x is positive, at x equal to 0 it is equal to 0, and for x less than 0 it is equal to -1. So we should check the signum of fractional part of x minus half also. Let's check when the input of the signum becomes 0. So from here fractional part x becomes half and x lies between 1 and 3. So from here we can say for x is equal to 3 by 2 and 5 by 2, the fractional part becomes 1 by 2. So now let's redefine the g of x when x lies between 1 to 3. Since the suspicious points are 1, e, 2, 3 by 2, 5 by 2 and 3 also. So define interval according to these points. So first of all x belongs to 1 to e. For x equal to 1, this log becomes log of 1 and log 1 is 0. 0 into anything is 0. Any other value greater than 1 up to e, it becomes 0 positive, and the greatest integer of 0 positive is again 0. So 0 into anything is 0. So overall the function becomes 0 for this interval. Now at x equal to e, this log becomes log e, and greatest integer of that log is 1 and the greatest integer of that is also 1. And inside signum we'll use the property, since we know that the fraction part is always x minus greatest integer of x. So fractional part of e becomes e minus greatest integer of e, which will give us e minus 2, because e is the Euler number, which is approximately 2.7 and greatest integer of that is 2. So using this value we get signum of e minus 2 minus half, which is ultimately signum of e minus 5 by 2, and this e minus 5 by 2 is positive. Signum of positive will give us 1. So overall at x equal to e, this becomes 1 and this is also 1. So 1 into 1 is 1. Now for x from e to 3. Now since x belongs to e to 3, so on taking log of x we get log e to log 3 as output. Log x belongs to log is 1 and log 3 clearly says that this log x is greater than 1 but less than 2, because log 3 is less than 2. So that clearly means if I take the greatest integer of this log x, we will get 1. So here we'll write 1. we know the graph of the signum function, and from 0 to 1 the equation becomes x, from 1 to 2 the equation becomes x minus 1, and from 2 to 3 it becomes x minus 2. So at x equal to e, this equation becomes e minus 2. We will use this in the function. So for the given interval we get signum of e minus 2 minus half, and this becomes signum of e minus 5 by 2, which again becomes positive, and signum of positive is always 1. So between this interval log x is 1 and signum of fractional part x minus half is also 1, so 1 into 1 is 1. Now at x equal to 3, we get log 3 greatest integer signum of fractional part of 3 minus half. Since we know the log 3 is greater than 1 but less than 2, so greatest integer is 1, and signum of fractional part of 3 is 0, and minus half as it is, so ultimately it becomes signum of negative. So signum of negative will give us minus 1 always. So at x equal to 3 we get minus 1. So gx is redefined like this for the given interval. Now let's check the continuity where the interval changes. So we can see at e the interval changes, and also at 3 the interval changes. At x equal to e, left hand limit is equal to 0, because for left hand limit the interval becomes this and the function becomes 0, and right hand limit becomes 1, because for right hand limit the interval is this and the answer is 1. So clearly left hand limit is not equal to right hand limit, so this means function is discontinuous at x equal to e. Now at x equal to 3 the left hand limit is equal to 1, because for the left hand limit the interval is this, which is equal to 1, and f of 3 is equal to minus 1. We cannot find the right hand limit here because the function is defined up to x equal to 3, so the values are not equal, so clearly this is also discontinuous. So clearly number of points of discontinuity is equal to 2, that is at x equal to e and 3.